Hello there and welcome to this course on embedded systems development using STM32 microcontrollers. In this course, I'm going to focus on teaching you how to use the hardware abstraction layer and also bare metal programming. So what I basically mean is that even though we are going to use hardware abstraction layer, we are going to write the code by hand without using any of the code generators that comes with the IDE, and specifically I mean CubeMX. And my reason for that is over time I have learned that it gets in the way of understanding, right? So I have a love-hate relationship with it, and I feel for you to have a very solid foundation and understanding of what goes on in embedded systems development, it is important that we stick to the hardware abstraction layer first, and after we have learned how to use that very well, we will get to the bottom where we are going to do bare metal. So I'm going to take a top-down approach instead of a bottom-up approach. And in my own experience, I have realized that this also works better, because once you start doing bare metal programming, if you have something to compare it to or its equivalent in the hardware abstraction layer, it makes the understanding a lot more easier. So let's cut all the unnecessary stuff that could cause delay in this course, and I'm going to tell you right away to install the STM32CubeIDE. I'm not going to show how to install that because it's pretty simple. Just Google STM32CubeIDE, come to their website, get a software. It's going to require that you create an account, create it, log in, download, and just install. If you are facing challenges, there are hundreds of thousands of videos on that, so I'm going to spare you that time. And as far as the hardware is concerned, I'm going to switch to the workbench, and I'm going to show you some of the dev boards that you can use. So over here I have an STM32F3 discovery board, but you can also use any of the nuclear boards. So I have a nuclear board also here. Sorry about this camera. I have a better camera, but I'm going to stick to this one for now. So this is it, and you can also pretty much use just any of the boards out there. Okay. All right, so now I'm going to assume that you have downloaded the software, and I'm going to show you how to create a project and also control your GPIO. Let's see how long we have here. Okay, 30% maybe we get through. All right, so I have already installed STM32CubeIDE, and I'm going to show you how to create a project. So you go to File, New, STM32 Project. And this is also one of the things I don't like about this IDE. Like I said, I have a love-hate relationship with it. So when it comes to debugging, it has the best of experiences out there, but when it comes to code editing itself, it's a disaster, and general speed is also a problem. As you can see, initializing target selector is taking significant number of seconds. So all right, so you're going to be presented with this board selector or MCU selector dialog. Essentially, if it's a custom hardware that you have made, and we'll get there, we'll learn how to create our own custom PCBs, but until then, this is what you get. So if it's a custom hardware that you have made, then you do MCU or MPU selector. So you type in the part number here and then you select, but we are using a board, so you click on the board selector, and again I have to wait for 1,000 years for it to load. All right, so then you begin to type STM32F3 discovery. So this is the board that I have. You click on it, and a picture of the board is going to appear down here, and then you click on next, and this is where you have to select, give your project a name. So I'm going to call this STM32F3 playground, because this is where we'll try a lot of things. You can program this board using either C or C++. We're going to go with C, and you choose the target binary type. Do you want an executable, a static library? We want an executable. And the target project type. So this STM Cube, if you select this option, is going to set up the project such that the hardware abstraction layer is already included. So all the libraries that you need, the header files and the source files that you need to be able to use the hardware abstraction layer, is automatically pulled into the project and linked for you, so you don't have to do anything. You can also of course, another thing that it adds is the ability to generate code using CubeMX. Even though I'm going to go with this option, we will not use the code generation capability. So we will actually delete that from the project, and it's not going to affect anything. And once we get advanced, we'll start creating empty project where we will manually download the hardware abstraction layer library and set them up. So for now, let's take baby steps and stick with STM32. You click next, and it's going to download this library and set it up for you. So you click finish. It's going to ask you initialize all peripherals with their default modes. No. So if I clicked yes, it sort of has access to the hardware description of the board, and so the code generator will leverage that information to initialize all the peripherals and components on the board, making them ready for use. But we don't want to do that. We are actually not going to use the code generation feature. So I just clicked no, and once again we have to wait for it to finish creating the project. Yeah, this is one of the things I don't like about this idea. And by the way, they have invested in creating an extension for Visual Studio Code. I have tried that also, and whilst I like the code editing capability, because of course Visual Studio Code has one of the best IntelliSense, when it comes to flashing and debugging, there's still a lot more to be desired. So I'm not gonna use that until that tool is also better. All right, so now we have our project created, and you are met with this IOC file, which is here, and this is the graphical user interface they give you so that you can click around to generate code. But like I said, we are not going to do any of that. So at least now we have a project created. I don't want the videos to be too long, so I'm going to end it here, and in the next video I will show you how to control GPIOs, sort of the hello world of embedded systems. So thank you very much for watching this, and I will see you in the next video.